I promised to discuss accommodation in piecemeal fashion, and this is a small piece of it. Prescribing reading spectacles, and all that I'm going to add to this is don't try this in clinic. But don't quote me on that. Okay, anyway, the idea is that if someone can achieve but not sustain 5 diopters of accommodation, what does that mean? It means that the accommodative amplitude is equal to 5 diopters. Then the amount that he or she can achieve and comfortably sustain is equal to accommodative amplitude divided by 2, which in this case is equal to plus 2.5 diopters. Now, if let's say that we have a different patient and his accommodative amplitude is only equal to plus 2 diopters, so that he can achieve and sustain. So this is achieve but not sustain. Achieve and sustain plus 1. And let's say that we want to prescribe spectacles that allow him to read at 1/3 of a meter from his face. If he were pseudophakic, if his accommodative amplitude were 0 and he were emmetropic, then 1/3 of a meter would mean that he would need a plus 3 add. But we're saying that he can deal with accommodating plus 1. So we need to have plus 3 for our total dioptric power, and that is going to be his reading spectacles plus his accommodative amplitude over 2. So we're saying with this guy, the accommodative amplitude over 2 is equal to plus 1. Therefore, the reading spectacles that we're going to prescribe are plus 2, because these are spectacles that will still allow him to use 1/2 of his accommodative amplitude, which he can do comfortably. However, if you're measuring accommodative amplitude in clinic, then you're only going to get through seeing 1 or 2 patients in half a day, which is not going to make you the most popular resident in the program. Okay, the same thing can be said about ametropic patients. So let's say that we've got someone who's -3. Well, we can do the exact same thing. We say -3, and let's say that this person's accommodative amplitude is equal to plus 2, which means that the accommodative amplitude over 2 is equal to plus 1. And we already did this calculation, and we said, well, what this guy's going to need is plus 2. Well, what he's going to need is a plus 2 add to comfortably see something that is at 1/3 of a meter. And I'm arbitrarily giving you 1/3 of a meter, because that's the figure that's often given in problem sets. Okay, so what if we were to give this person spectacles? I think that I'm out of your field of view here. So he is a -3 diopter myope. Okay? And we're going to give him a plus 2 add, and he says, well, I don't really want bifocals, I only want single vision reading glasses. What is it going to be? Well, it's going to be the distance plus the add. So -3 plus 2 means that we're going to give this person -1, and that's going to be his reading spectacles. Now, we don't usually talk about accommodative range with spectacles on, and in fact, that doesn't make sense. Accommodative range means with spectacles off. But if we were to ask the equivalent question, sort of what we're doing with this patient's range, the -3 myope who has an accommodative amplitude, so this is his distance Rx. Distance is equal to -3. His accommodative amplitude is equal to plus 2. Okay? Now, I want us to keep our signs straight here. A distance, an accommodative amplitude is a description of what's going on at the level of the eye. The distance correction is the opposite of what's going on with the eye. A -3 myope is a -3 myope because he wears -3 spectacles. In fact, his eyeball is over +3. So the -3 myope is already starting out with +3 extra diopters in the front of his eye. That's why he has to wear -3 spectacles. So he's +3, his accommodative amplitude is +2. His near point is going to be at 1/3 of a meter from his face. Excuse me, his far point. His far point is going to be at 1/3 of a meter from his face. His near point, well, we just add these up. Amplitude plus his native uncorrected error is +5, means that his near point is going to be at 1/3 of his face. Excuse me, at 1/5 of a meter from his face. His accommodative range is from 1/3 of a meter. Oops, 1/3 of a meter to 1/5 of a meter. And if his accommodative amplitude is +2, what is the add that we're going to give him to see something that is at 1/3 of a meter? First of all, I can tell you, when this guy wants to see something at 1/3 of a meter, he's just going to take his spectacles off. But fine, let's go through the exercise of prescribing bifocals for him. So his accommodative amplitude is +2. This is what he can achieve but not sustain. He can achieve and sustain half of this, which is going to be +1. So +1 is going to be his contribution from himself towards the +3 that we want to get him in order to see something that's 1/3 of a meter from his face. So we're getting +1 from him, plus whatever Rx we're going to give him is going to have to equal +3. Therefore, the Rx that we're going to give him is going to be +2. This refers to the add. So his spectacles, we said he's a -3 myope. So he's going to be -3, and we're going to say with a +2 add. Or if we're prescribing straight reading spectacles for him, then we're going to give him reading spectacles of -1. Why? Because it's -3 plus 2 is -1, and this is going to allow him to accommodate his 1 diopter anyway. Now, just some parting thoughts on prescribing actual bifocals. One of them is this. Many people for progressive lenses will prescribe an extra plus 0.25 diopter add. And they do this because this way patients don't have to look down to the very bottom of the progressive segment in order to get the add that they desire. Now, a lot of this is predicated on the design of the progressive lens, and I don't know that I would automatically do this. Also, I've had optical shops just on their own add plus 0.25 on to my prescription when they are doing the ad for the progressives. And frankly, it's kind of like adding the tip onto a bill at a restaurant that you have to know whether they're adding the tip on for you so you don't double tip. You also want to make sure that the optical shop is not on its own adding on plus 0.25 and you're doing it, or you're in essence going to double tip there too. The other thing is frankly far more critical than figuring out exactly what someone's accommodative amplitude is to establish working distance. Because tall men with long arms tend to hold things further from them than short women with short arms. And you need to establish what this working distance is before you prescribe the appropriate spectacles. Because if, let's say, we have a tall gentleman who enjoys holding things at 1/2 of a meter, then the maximum ad, even if he were pseudophakic and emmetropic, the ad that you're going to give him is only going to be +2, because this is the distance, this is the power that corresponds with his working distance. So, in clinic, I generally don't measure the accommodative amplitude, but I will give someone, give the patient some reading material. If they brought something with them, then that's great, and if not, then a magazine from the waiting room, and ask them just to hold it and explain to them that I want them to hold it not at the distance at which it comes into focus with his spectacles, or at which it comes into focus without his spectacles, but to hold it at the distance at which he wants things to come into focus, and then I'll prescribe to that distance. So that the inverse of that distance gives you what the patient's maximum ad is, and then you can factor in the accommodation that the patient is willing to contribute, which is something that I factor in. It's just that although it's important for you to understand how it's measured, it's impractical to do it very often in the context of your own practice. Thank you.